Okay, so in this video tutorial we're going to be talking about the kinematics and freefall practice, where most of these are at a upper level from what we've been doing. And this is just really to provide you some background for the ones that you're having difficulty. But as always, if there's any questions on any of these, please feel free to come talk to me, and we'll make sure that you're on the same page as the rest of the class. So if we look at the first question, it's a person driving where we want to compare what is the difference in stopping distance between the person that is under the influence and the person that is more alert. So one way to think about this, and this probably ends up being the easier way to think about it long term, is think about it in terms of a graph. So if this purple line represents the more alert person, and it takes them 0.56, so this is 0.56 seconds, and we're looking at a V versus T graph here, before they actually start to break from 30 down to 0. And then the other person, the person that's under the influence, is going to take twice the amount of time to react to it. So they're moving at that constant 30 meters per second for twice the amount of time, and then they break at the negative 6.8 meters per second, and then stop. So if we think about what this area represents, it's the displacement of the two drivers. So if we look at this graph, the area of these two triangles would be the same, and you can actually work this out. It should be 66.2 meters, the area underneath both of these triangles. But the extra distance that the person who is under the influence is driving, notice that it's just jet out by this much right here. So the extra distance traveled by that is going to be equal to the extra distance, the extra area, which really is just a rectangle. So it's really just the length times the width. So the most straightforward way of dealing with this is taking that extra time, which is 0.56 seconds, and then multiplying it by the 30 meters per second. And that gets you the 16.8 meters. Now what you could do is you could figure out the area for both of these shapes, so the purple shape and then also the red shape, and then subtract them. But at the heart of it, it's really just this extra rectangle where the person that's under the influence is taking longer to react. All right, so the next one, there's two approaches. I'm going to actually share both approaches so you can kind of get an idea for how to solve it. The most straightforward way is actually using this relative motion. So we have a ram, so we have, think about there's a 30 meters, we have one ram on one side, so here's the first ram, and then here's the second ram, and they are initially 30 meters apart. All right, so the distance between these 2 points is 30 meters. So, let's say the ram 1 is moving slower, so we can kind of reason out that it's going to be a little closer to ram 1. So I'm going to call that distance x. So if this distance is x between ram 1 and their collision point, okay, and let's call that, let's just call this their collision point, that if that distance is x, then this distance between ram 2 and the collision point would then be 30 minus x. And then from a relative motion standpoint, what we would have is the velocity of ram 1 relative to the ground is going to be, I'm going to say to the positive direction is to the right, so that is going to be a plus 10 meters per second. And then the velocity of the 2 relative to the ground would be, since the ram 2 is moving in the negative direction, that's going to be a negative 12 meters per second. But if I want to get the velocity of 1 relative to 2, so the velocity of 1 relative to 2, remember how we set this up with relative motion? That would be the velocity of 1 relative to the ground plus the velocity of the ground relative to ram 2. So this is a given here, that's the plus 10 meters per second. And then I add, well, if the 2 relative to the ground is negative 12, then the ground relative to 2 will be a positive 12. Right? One way to think about this is that they would be approaching each other at a 22 meters per second. And then, in order to figure out the time is going to be the distance divided by the average speed. And I got there. I did a little algebra first. So cross multiply v times t and then divide by v. We get the distance traveled divided by that average relative speed. And so the distance is 30 meters. The average speed is 22 meters per second. And so we get 1.36 seconds. So this ends up being probably the more straightforward way of doing it, but I want to talk about how we might go about solving it with this approach here. So I'm going to erase this, and certainly on a test or quiz, if this approach makes more sense and certainly is the easier one, then by all means go for it. All right, so the second approach deals with the fact that when they collide, not only are they at the same position, but it has to occur in the same amount of time, meaning that the 1.36 seconds for ram 1 to travel, the 1.36 seconds for ram 2 to travel. So it's at the same position at the same time. So we're going to basically write an equation for both ram 1 and ram 2. All right, and so actually one way I can erase this. All right, sorry for the delay. All right, so we know that if velocity is equal to the displacement over the time, the change in position over time, then what I can do is I could write the change in position for ram 1 is the velocity of ram 1 times t, and then the change in position for ram 2 is equal to the velocity of 2 times t. Okay, and once again, that position, that final position, is going to be the same for each of them. So what I said for the change in position for the displacement for ram 1, I'm going to denote the letter x. So this is x. I'm going to actually just plug in the 10 here, plus 10, times t.